Let's see the problems on method 4. First, we shall see the integrating factor we use for this method. So, to find an integrating factor of mdx plus ndy is equals to 0, if there exists a continuous and differentiable single variable function, that is g of y, such that dou n by dou x minus dou m by dou y divided by m is equals to g of y. So, when we solve these, we get a function in terms of y variable. Then e power integral of g of y into dy is an integrating factor of mdx plus ndy is equals to 0. So in this case we use this e power integral g of y into dy as the integrating factor. So when we solve this equation, when we use this formula, we get g of y. That means we get a function in terms of y variable. So let's see two problems on this method. Solve xy cube plus y into dx plus 2 of x square y square plus x plus y power 4 into dy is equals to 0. So it is in the form of mdx plus ndy is equals to 0. So m is xy cube plus y and n is 2 of x square into y square plus x plus y square. So when we simplify this, we get 2x square y square plus 2x plus 2 into y power 4. Now differentiate it, functions m and n. So that is dou m by dou y, that equals to dou by dou y of x into y cube plus y, that equals to x into y cube differentiation is 3y square plus y differentiation is 1, and that equals to 3x into y square plus 1. So now differentiate the function n with respect to x, that is dou n by dou x is equals to dou by dou x of 2x square y square plus 2x plus 2 into y power 4, and that equals to 2y square is constant and x square differentiation is 2x plus 2x differentiation is 2 and 2 into y power 4 differentiation becomes 0. That equals to 2 into y square into 2x is equals to 4x y square and then plus 2. So when we see these two functions, dou m by dou y is not equals to dou n by dou x. So you can say that it is not exact differential equation. Then we consider dou n by dou x minus dou m by dou y divided by m, that equals to 4 into xy square plus 2 and dou m by dou y is 3xy square plus 1. So when we multiply with this minus, we get minus 3xy square minus 1 and then divided by m, that is x into y cube plus y. So this m we had to write here. Then simplify this further, we get 4 into xy square minus 3xy square. This is x into y square and 2 minus 1 is 1 and divided by xy into y cube plus y, that equals to in the denominator take y as common, so we get y of y square plus 1, sorry, y of x into y square plus 1. So the both terms gets cancelled and it remains 1 by y. So this is g of y. So g of y is equals to 1 by y. Now we find out the integrating factor. So integrating factor is e power integral g of y into dy. So e power integral g of y is 1 by y into dy, that equals to e power integration of 1 by y is log y. So that equals to y. So the integrating factor is y. So now multiply the integrating factor to the given question. So x into y cube plus y into y dx plus 2x square y square plus 2x plus 2 into y power 4 into y into dy is equals to 0. So this is a function m1 and this is a function n1. So simplify this, multiply this y to the inside terms, then we get x into y power 4 plus y square and n1 as 2x square y cube plus 2xy plus 2 into y power 5. Now differentiate m1 and n1. So dou m1 by dou y is equals to dou by dou y of x into y power 4 plus y square. So here x is constant and y power 4 differentiation is 4 into y cube. So that is 4xy cube, and y square differentiation is 2y. Then also differentiate function n1. So dou n1 by dou x is equals to dou by dou x of 2x square y cube plus 2xy plus 2 into y power 5. So that is here 2 and y cube is constant and x square differentiation is 2x. So 2 into 2 is 4. So we get it as 4x y cube. And 2xy, in this 2y is constant and x differentiation is 1. And 2 into y power 5 is differentiation becomes 0. So we get 4x into y cube plus 2y. So dou m1 by dou y is equals to dou n1 by dou x. So these two differentiations are equal. So the both are equal, and then it is exact differential equation. So once it is exact, we can find out the general solution, that is integration of m1 dx plus integration of n1 dy is equals to c. So now m1 you substitute here. The terms are x into y power 4 plus y square. So write the integration separately. So integration of x into y power 4 dx plus integration of y square into dx plus n1 function, that is we have three terms here. So write the integration separately, that as integration 2 into x square y cube dy plus integration of 2xy dy plus integration of 2 into y power 5 dy is equals to c. So here y power 4 is constant and integration of x dx plus y square is constant and integration of 1 dx. This value becomes 0 because x is present. We know that in function n1 x term should not be present, but there is x term in this, so this value becomes 0. And similarly here also we have the x term, then its values become 0. But in this last term there is no x variable, so we can integrate it. So here 2 is constant, so 2 into integration of y power 5 dy is equals to c. So y power 4 integration of x is x square by 2 plus y square integration of 1 with respect to x is x plus 2 into y power 5 integration is y power 6 by 6, that equals to c. So simplify this further. We get x square into y square by 2 plus x into y square plus 2 ones and 2 threes are. So here y power 6 by 3, that equals to c. So this as a general solution, or you can even take the LCM here and bring this 6 to the right hand side, and that multiplies with the constant c, or you can even leave it like this. And let's see one more problem on this method 4. So solve the differential equation y plus y square into dx plus xy into dy is equals to 0. So here it is in the form of m dx plus n dy is equals to 0, and m is y plus y square and n is xy. So differentiate this dou m by dou y, that is dou by dou y of y plus y square, and y differentiation is 1 and y square differentiation is 2y. So dou n by dou x is equals to dou by dou x of xy, that equals to xy differentiation is 5, since x is constant, y is constant here and x differentiation is 1. So we see the here differentiations, they both are not equal, so we can say that it is not exact differential equation. So we make this as exact by multiplying with a suitable integrating factor. So then g of y is equals to dou n by dou x minus dou m by dou y divided by m, that equals to y minus of 1 plus 2y by 1 y plus y square. So multiply this minus inside the function, then y minus 1 and minus 2y divided by y plus y square, that equals to y minus 2y is minus 5, and here minus 1 is there. So minus 1 minus 5 by y plus y square. So in the denominator we can take y common. So when we take y common, it becomes as, and in numerator also we are taking minus common, so that becomes minus of 1 plus y divided by y of 1 plus y. So 1 plus 1 plus y will be get cancelled, and we get it as minus 1 by y. So this is the function g of y. So then e power integration of g of y dy is the integrating factor. So e power integral of g of y is minus 1 by y into dy, that equals to e power, right, minus outside, and minus integration of 1 by y dy, that equals to e power minus 1 by y integration is log y, that equals to e power log y power minus 1. So here minus 1 is sent to the power here, that is y power minus 1, that can be written as 1 by y. So this is the integrating factor. Now multiply this integrating factor to the question, then we get it as y plus y square by y dx plus xy by y into dy is equals to 0. So this is the function m1 and this is the function n1. So here take y common in the numerator and this will be cancelled. So we get it as 1 plus y and n1 is equals to x. So dou m1 by dou y is equals to dou by dou y of xy, sorry, 1 plus x. So and here y constant in differentiation is 0 and y differentiation is 1. So we get it as 1. And similarly dou n1 by dou x is equals to dou by dou x of x, that equals to 1. So when we see both of these differentiations, they both are equal. So it is exact differential equation. Then we go with the general solution, that is integration of m1 dx plus integration of n1 dy is equals to c. So integration of m1 function and integration of n1. So here 1 dx, integration of 1 dx plus integration of y dx, this integration becomes 0 because x is present here, that equals to c. So one integration is x and y integration is, here y is constant and one integration is also x again, that equals to c. So take x common here, we get x of 1 plus y is equals to c. So this is the final general solution for the given question. So in this way we solve the method 4 problems.